Yes, hey guys, and welcome back. And today let's solve diagonal traverse. So yeah, again the question is pretty straightforward. You will be given a matrix or two-dimensional array, and you have to traverse it diagonally. So what does diagonal mean? So first you have to go to 1, and then you'll go to 2, 4, 7, 5, 3, 6, 8, 9, and so on. So yeah, in a zigzag manner. In other words, you traverse through each diagonal, and whenever you traverse through each diagonal, you reverse the direction of travel. So for one you're traveling from left to right, and two to four you're going right to left, left to right, right to left, and all. So yeah, you can do it in a brute force way where you have a pointer, and for each column, what what you'll do is you'll start a diagonal traverse. From here you'll start one diagonal traverse. Here you'll start one. Here you'll start one. And then after you reach here, what you have to do is again for the last row you have to go through each column again and start another diagonal traverse to get all the values. Yeah, that is possible and doable, but yeah, that simply increases the complexity. And again, if you know the properties of matrix and a little bit of math, then this problem becomes really easy. So the main ideology behind it is to add the values of every row and column, not the individual value, but the indexes. So consider the given matrix itself. It is 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's not write it in terms of the elements, but in terms of coordinates. So 1 is at 0, comma 0, and then 2 is at 0 comma 1, and I'll not keep on reiterating it. Yeah, second row it will become 1, and the third row it will become 2, mainly because it's 0 based indexing. Okay, yeah, this is the coordinate form of the matrix, and what you do now is add each value. Example 0 comma 0, you will add 0 and 0, it will become 0, and then 0 and 1 will become 1, 0 and 2 will become 2, 1 and 0 will become 1, 1 and 1 will become 2, and 2 and 1 will become 3, and again 2 and 0 will become 2, 2 and 1 will become 3, and 2 and 2 will become 4. So what do you see? You see that every diagonal, the value of added values are the same. So 1 and 1 1 is another diagonal, 2 2 2 is another diagonal, 3 4 3 3 is another diagonal, and 4 is another diagonal. So yeah, as soon as you see that, you should be able to guess that we can use a dictionary to store each and individual added value, and if the added value already exists in the dictionary, then that is a diagonal, and we have to add the specific value to the diagonal. So whenever you come across 1, you will add it in the 0th value, and whenever you come across 2, it will be added in 1 value, 3 will be added in 2 value, 4 will be added in 1 value, 5 will be added in 2 value, 6 will be added in 3 value, and so on. So yeah, then now rather than brute forcing your way through it, doing it becomes very easy. So yeah, again, whenever you can use dictionary, you can use default dictionary to make your life easier. So let's declare the dictionary. Yes, and then what you'll do for I, and since it is given the matrix is m cross n and not m cross n, you have to, the second loop should start from the to take the length of the first row itself. Row is I, so what you have to do, calculate the value, and then d at the position value, what you will do, you will directly add the matrix at position aj. And now after you reach, after you finish any major part, always print out the values and check if you made an error. So let's just print out the dictionary. And let's look at the dictionary. We have 1 2 4 3 5 7 6 8 and 9. So it is 1 2 4, and then 3 5 7 and 6 8 9. So yes, for each, now what you can do is you can go through each value, and then you can have a flag variable, and the flag will keep on switching for each iteration, and when you have switched flag, you will append the reverse value, or else you will append the proper value. So declare a flag, and then what you will have is the answer array. and then for I d dot keys, if flag exists, then what you will do, you will add the reversed value. So, and what you know is that each value is inside an array, so you can directly use extend rather than again going through each array again and again and adding the values. You can directly extend d at the position I, but when flag exists you have to do reverse. Else, if the flag does not exist, then you can add the proper value. So what you'll do, d at the position I itself, and after each iteration you have to reverse the flag, and it is not flag. And just let's check it out once. Okay, yeah, I just made a small mistake over here. Just I reversed the wrong part. Yeah, mistakes will happen. And it's compiling. Now just submit it. And yeah, there are so many submissions that my submission got overshadowed by others. But yeah, the solution works, and yeah, it is a pretty ingenious way to do it, rather than keeping doing it in brute force way where you declare a pointer, go through each row, and then for each column, and then for last row you go through each column again. This makes your life much easier. So yes, thank you for watching.